So here's our bacterium here, and behind it will be these long strands that are the bundle-forming pilus. They're going to adhere to the microvilli, these wiener-like structures. This is what your normal intestinal cell surface comes along here. Bacterium then causes these things to disappear. It then starts to nestle down on the surface. It's locked in. And then it's going to come down, and it's going to set up camp right there. We know that happens because we can see this in electron micrographs, and the microvilli all disappear, and boom. Okay, so we're now stuck in the intestine. Bacteria are here. We're going to zoom in. Here's our type 3 secretion system, right? This thing will poke out. We know protein comes out. We know this protein. And then it inserts 2 more proteins that come out and down this tube, and they go into insert into the host membrane. So these green proteins will sort of form like a donut pore, and this is kind of the tip of the syringe. Then we have to fire in the receptor, the tear molecule, and you'll see it as this red molecule coming down the chutes, and it gets then fired into the host cell. Then it goes into the host cell. We don't know if it goes through the cytoplasm, goes straight in the membrane. We haven't figured this out. You'll see a little blue dot. That's a tyrosine phosphorylation event. Tear gets modified. Then it ends up in the host membrane. So here we're piling the receptor into the host cell. And then we then have to dock tear with intimin. So we think this tube-like protein retracts. And what will that then do is bring the bacteria down into contact. Here's intimin up here, blue tear here. Houston, we have contact. We have now landed. Bacteria is stuck on this cell. And now we're going to go inside the cell, and we're going to start to see the face of tear that's facing. It recruits cytoskeletal proteins and these little donut-shaped things we are starting to understand more. Then you're going to see little yellow beads come flying in. These are actin monomers. They then get together, and it's like a string of pearls. They polymerize. See these things flying in. They then start to get longer and longer, and actin does this for a living. It forms these long projections, strings of beads. And what that will start to do is start to put a force on this thing, and you will then start to see the bacteria actually raise up on the cell. And it's because there's actin pushing underneath it that it actually pushes it up into the cell. There it goes. And then it starts to push up. Bacteria starts to raise up. It's now building its throne. Then I'm going to sit up on top of this thing and rule out over it. And if this doesn't want to make you be a microbiologist, I don't know what will. Isn't this a thing of beauty? And then it just continues to rise and rise and rise. And the end result is we then end up with the bacteria sitting up on this throne, shall we say, to rule out over the mammalian cell. And that's what we see in disease.